Okay, day 2 this week in review is on combining like terms and then solving two-step equations from that. So to start, we're going to start with combining like terms. So if you look here at our expression, and we consider how many terms are there. Turns out that there are 4 terms there. You have 7y, the 10, or the positive 10, that negative 3y, and then negative y squared. Okay, so there are 4. Because these are the numbers and or variables that are separated by a plus or minus sign. Okay, so you can see when they're separated by the plus or minus sign, there are 4 different terms there. 7y, 10, 3y, and the y squared. So how many coefficients are there? Coefficients are those numbers that are multiplying with a variable. In this case, there are 3 coefficients. You have the 7, that's with that y in the first term. You have the negative 3, that's paired with the y here in our third term. And our last coefficient is actually our negative 1 there. There's a negative 1 y squared. Constants. Okay, constants are the numbers that are by themselves. No variable. There are 1 of those. What's that? Positive 10. No variable attached to it. Our like terms are the ones that have the same variable to the same exponent. So the like terms in this one here are the 7y and the minus 3y. Because they're both a y variable to the power of 1, to the same exponent. All right, we can't combine it with the y squared because of the different exponents there. Okay, so the y squared is by itself. The 7y and the minus 3y are like terms because they have the same variable to the same exponent. And don't forget, if there were more constants here, constants are also like terms with each other. Okay, so let's get some practice in. I'll do the first one, and then you guys should try the second 2 on your own before looking to see how it's done and what the answers are. So, letter A here, I'm looking for like terms. I see a 6, the positive 6x and the minus x are both x to the first power. All right, so if I have positive 6 of those and I subtract one of them away, remember this is minus 1x, I would have 5 x's left over when I combine those. I also have a positive 11 and a minus 4. Those are our constants that are like terms. Positive 11 minus 4 is going to leave us a positive 7, and that's my answer. 5x plus 7 when I combine the like terms. Again, I can't combine the 5x and the 7 because they're not same variable to the same power. So go ahead and try the other 2 here. See if you can get these by yourself. Alright, so if I'm combining like terms here as well, I can see like terms here in the 3x and the plus 1x because they're the same variable to the same exponent. So 3x's plus 1x is 4x's. I don't see any other y's in this expression. So I think the 8y just gets to stay as it is. And actually, that's the same case for this minus 2 here. That's also going to stay the same. So no changes there. The answer then is 4x plus 8y minus 2. Okay, and our last one here. I don't see any other x squareds or x to the second powers. So the 2x squared gets to stay exactly as it is. When I look at the x's here, I see a minus x plus 13x. Again, that's x to the first power. So if I have minus 1x plus 13x's, if I have negative 1 plus 13, that leaves us with positive 12x's. And for our constants, I have a negative 13 plus 6. 13 spots to the left from 0, 6 spots to the right. I'm still going to be in the negatives. It'll be at negative 7. So the expression combined here is going to be 2x squared plus 12x minus 7. Okay, so now on to two-step equations. Two-step equations use the same skills from the one-step equations. Okay, we will want to make sure that we always do the addition subtraction first, and then finish with the multiplication division to isolate the variable. Remember, our goal here is to isolate the variable or get it by itself on one side of the equal sign. Okay, so if you were to draw a dotted line down your equal sign here, and I start with 2x plus 3, my first job is to get rid of that plus 3, get rid of the constant first. And the way to get rid of a positive 3 is to bring in a negative 3, or subtract 3 away, right? Because positive 3 and negative 3 will cancel out. But if I do it to this side of the equal sign, I also do it to this side. 9 minus 3 leaves 6 on the right side of the equal sign here. So now I have 2x equals 6. To get rid of the 2 with the variable, that's the coefficient here, 2. Since this is 2 times x, the opposite of multiplying by 2 is to divide by 2. And we divide by 2 on both sides. That gets rid of the 2's, so it's x by itself. And 6 divided by 2 is 3. So x would have to equal 3. Okay, if I wanted to check to see if this is true, I would substitute 3 back in for x. Two times 3 is 6, plus 3 is 9, so that does check out. Okay, be patient, do one step at a time. There's no need to rush. You don't want to accidentally multiply when you should have been adding or subtracting. So go ahead and try these out on your own. Okay, I'm going to start by drawing my dotted line down the equal sign. My first step here should be to get rid of this positive 2. The opposite of plus 2 would be to subtract 2 from both sides. Positive 2 minus 2 cancel out, so it's just going to be a 3x here. And 23 minus 2 is 21. To get rid of the 3 coefficient with the x here, since this is 3 times x, I would divide by 3 on both sides. 3 divided by 3 is 1x equals 21 divided by 3 is 7. Again, I could plug that 7 back in. Seven times 3 is 21. And 21 plus 2 is 23, so that checks out. Okay, let's try it here. My first step here is to get rid of the minus 7, the constant here, and the opposite of minus 7 would be to add 7 to both sides. Minus 7 plus 7 cancels out, so that leaves just the minus 2y, or the negative 2y, and 3 plus 7 is going to be 10. My next step would be to divide both sides by the coefficient. In this case, that coefficient is negative 2y, or by negative 2. All right, we divide by negative here so that when I do negative 2 divided by negative 2, it comes out as a positive. I want a positive 1y. All right, so to get rid of the first negative, I got to bring in its pair to cancel it out for division. Negative 2 divided by negative 2 is positive 1. 10 divided by negative 2 is negative 5. All right, we have a fraction here. It's going to be no different. My first step is to get rid of the constant. So the positive 4 and the negative 4 cancel out, leaving me with 1/5 x equals negative 5. Negative 1 minus 4 is negative 5. Right? If I were to lose $1 and then lose 4 more, I'd be at negative $5. Similar thing here. To get rid of the coefficient here, the 1/5, I just got to divide both sides by 1/5. One-fifth divided by 1/5 will still leave me with a 1, right? 1/5 divided by 1/5 is 1. When I do this one here, I have something like negative 5 divided by 1/5, right? And we can divide fractions. To divide fractions, you're going to keep our first one, flip our second one, and change to multiplication. Right, so negative 5 divided by 1/5 divided by 1/5 just looks like this. Keep the first, flip the second, and change to multiplication. Negative 5 times 5 is negative 25. And our last one. Same thing here, even though there's a decimal. I would subtract away our constant, right? Because positive 27 minus 27 cancels out, leaving us with 8.50n equaling 51. And to get rid of that coefficient again, we just need to divide. Since it's 8.50n, it's multiplying by the n. I divide by 8.50 on both sides. 8.50 divided by 8.50 is 1. And when I do the same thing to the other side here, this is going to be 51 divided by 8.50, which is 6. Okay, so remember, draw that dotted line down the equal sign. Make sure you do the same thing to both sides of the equal sign, and your job is to isolate that variable.